bits, maybe. So this is how you do the address allocation in an organization. I hope this is clear. Do you have any doubts? So the same thing is shown diagrammatically here. You can see out of the total size of the block, the organization gets 256 address, for which the prefix length defined was 24, out of which the first address is 14.24.74.0/24, last address is 14.24.74.255, last address. So this is the original block given to the organization. The subblocks are divided like this. The first subblock gets 128 addresses, starting with 74.0/25 to 127/25. That's the last address. The second subblock gets 64 addresses, or it needs 64, so it gets 64 addresses. The first address of this subblock is 74.128. Immediately the address next to this. And if you have verified, if you had a calculator, I think you would have verified that divisibility property will surely be satisfied. And the prefix length here is 26 bits. And the last address here would be what? 14.24.74.192. Okay. So here there's a mistake in writing. This shouldn't be, sorry. Here this 74 is missing. 74.192 it should be, not 74.0. In the notes or in the slides already circulated also, you please make this correction. So this is 14.24.74.192. That's the first address of the third subblock. And the last address of the third subblock would be 14.24. Whatever we designed just now. 14.24.74. So the first 3 bytes don't change. The last address is 207. Correct? And there are 48 unused addresses which can be allocated further by the organization as and when it is expanded. So this shows the address division diagram in the previous problem. So we have another important topic known as address aggregation. I'll just complete this another 5 minutes and stop. So what is this address aggregation? When I have multiple smaller blocks in an organization, I told you, just take the example of the previous case where there were 3 sub-blocks which may represent 3 buildings in a campus. Okay. For example, the 3 sub-blocks can represent 3 buildings in a campus. Now, should I represent each building separately to the rest of the world? The outside world will see all these 3 sub-buildings within the campus as RNSIT only. So, if there are 3 buildings in RNSIT, the whole world should see RNSIT as one unit. So, all these 3 sub-blocks will be aggregated and presented to the outside world or the internet as one unit or one large block. This property is called address aggregation. So, the smaller blocks join together. So, what do you think in the previous example? What would be the address of RNSIT? RNSIT as such would have the address. Anybody can tell me? Please send either
first address of the,
yeah, tell me. RNSIT on the whole will be defined with which address? In the previous example. You just talk, no, don't message. Yes, 14.24.74.0. So the 14.24.74.0 is the address by which the complete organization will be referenced. Okay. So the prefix value for the unused address, if you want, there are 48 bits of 48 unused addresses. What is the nearest number close to 48, which is a power of 2? Yes, Tejaswini. What is the number closest to 48? You want to know what is the prefix value for the unused addresses, right? So 64 is the nearest power of 2. So 64 is 2 to the power of 6, right? So what would be the prefix length? 32 minus 6, which is, how much is 32 minus 6? It is 26. So for the last set of unused addresses, the prefix length is 26 bits. Okay. Usually they'll not take that whole block as one. Why? Can somebody give me the reason why the whole thing will not be taken as one? If you notice in this diagram, can you see the prefix length going on increasing as we have changed? Why did this happen? Because we did the address allocation considering the longest block or the largest block first. Largest block was allocated the addresses first, then the next largest, then the next largest. So out of these 48, it won't be taken as one block as a whole. It will be divided into smaller sub blocks, maybe each of 16 addresses or 8 or 4, whatever you want. It will always be less than this. Clear? So if you want a larger block, that block allocation, address allocation should happen before than the smaller blocks. So I can't get a prefix which is 26, which is smaller than this prefix at the end. So when it is left at the end, it is usually for making smaller blocks which have addresses lesser than the previous blocks. Please keep it in mind. All these are some basics which you will remember during address division. Am I clear now? Okay. So I was explaining to you the concept of address aggregation. What do you mean by address aggregation? Address aggregation is a process where smaller blocks of addresses in one organization will be combined or aggregated. It will be combined and it will be represented as one large block to the rest of the world. So I was telling you in the previous example, if you consider each of the addresses divided as one academic block, the rest of the world will see RNSIT inclusive of all these three address blocks. So you can see here in this example, clearly we have explained what is address aggregation. You see here in this example, block 1 has starting address 160.70.14.0/26. The last address .14.63. There is a change in the last byte. So the prefix length is 26 bits. So totally how many addresses are there in this block? How many addresses are there in this block? 0 plus 63, which means 64 addresses.
64.
Yes. Similarly, block 2 has first address .64 to the last address .127, which is another 64 addresses. Block 3 has .128 to .194, another 64 addresses. So there is an equal division of addresses among the 4 sub-blocks. That means there are 4 sub-blocks in the organization and each of them have got 64 addresses. Now, we have an internet service provider like Reliance Jio or Airtel, Aircel, whatever. There is an internet service provider close by who is providing internet service to you. Assume this whole thing belongs to one organization, okay, like RNSIT. Now, the whole, each one belongs to one academic block. Now, the whole organization will be combined by this ISP and it will be represented on the internet by the address 160.70.14.0. That is the first address to the last address 160.70.14.255/24. So the complete organization will be represented on the internet or to the rest of the world as one unit, and this larger block is combined by this internet service provider. So the internet service provider shows the address for RNSIT as anywhere between this number, and the subdivision after, say I try to access a device, sorry, say I try to access a device with address 160.70.14.221. Say the device, the IP address of the device which I am trying to access is this. Then it is the job of the internet service provider. So from the outside world, it will simply come and sit in this router. This router is present with the internet service provider. So it has been routed to this point, this ISP, and now this router will separate it out and it will pass on the packet which has come with this as the destination address to which block. It should send it to the last block, because dot 221 is an address which belongs in the last block. It is between 192 to 255. So it belongs in the last block, and that job is carried out by this end router sitting in the internet service provider. Okay. So the rest of the world will see it as just one unit from here to here. The separation will be done at the end point or the last router, which is normally present on the internet service provider. So this method of aggregating all the addresses of the sub blocks into one large block of addresses to represent one organization to the rest of the world is called address aggregation. So as we have already seen, the initial bits represent the network prefix and the next bits represent the host address, and they are always in a two-level hierarchical structure. Leftmost n bits define the network or the net ID. Rightmost 32 minus n bits define the host. I'll continue with this in the next class.